Welcome to another unit in business mathematics. This time I'm going to talk about partial integration. And partial integration, or the rule of partial integration, is more or less the analogon for what with derivatives was the product rule. So here we're going basically to transform or use the product rule to get a rule to actually solve slightly more complex integrals. Let's have a look how we start with this, where we start, as I said, with the product rule for derivatives, which here I'm basically writing as a function h, whereof I want to get the derivative, and h can be split up into two partial functions, f and j. So if I get the derivative of this product, that's what I use at this point, the product rule for. What I'm going to do, I'm just reformulating this product rule in a slight way. That's what we can see here. What I did in this context is basically bring the last term on the right to the left. Once I have this reformulated product rule, I'm basically calculating the integrals on both sides. If I do this, first I have this part, here the integral, and on the right side I'm taking the integral of those two parts. However, as there is a minus in between, I can split up the integrals. That's actually one interesting side rule for integrals. What we know as linearity rule for derivatives works in the same way for integrals. So basically, if there's a plus or minus between two parts of a function, you can integrate them separately. And if there is a number, a constant in front of a function, you can also pull this number, this constant, in front of the integral. However, at this point, we are mostly interested in a minus here, which means we can split up this integral into one part and a second part, what we did here. Well, that's almost our rule for partial integration. The only thing we are still doing is considering this first part here. So in this case, we're basically integrating a derivative. This means those two things actually cancel each other out. So if we consider this, we get here simply f of x times g of x, because the derivative and the integral cancel each other out. This is what we usually call the rule of partial integration. In other words, we take a look whether we have a product of two functions where f, one part can easily be integrated and another part can easily be derived. Then, in the first step, we get the first part of our result by taking here the primitive of f, g as is. And in the second part, we are calculating the integral of the primitive of f times the derivative of g. This is actually the most critical part. This first part not so much, but this part here, because we need to select f and g in a way that this expression actually becomes easier to solve than the first one. So we are only selecting an f which, after integration, when moving from this side to that part, does not make this function more complex. It's best if it makes it a lot easier, but at least it shouldn't make it more complex. Well, that's basically already all there is on this rule on partial integration. And well, I say goodbye and see you next time.